Okay, so this lesson's over inverses, and there's kind of a lot more I could get into with this. But again, I'm trying to just hit kind of the basics of this. Hopefully, I'm hitting just enough that if you guys go on to pre-calculus or finite math or whatever you take, and maybe even the geometry a little bit, you talk about inverses, hopefully you kind of have a vague understanding of what those inverses are. So we have talked about inverses a little bit, where inverses are opposites of each other. So like the inverse of multiplication is division, the inverse of exponents is square roots, the inverse of an exponential is a logarithm. Those are all inverses that we've dealt with before. But what we're doing today is being able to recognize if things are inverses and how to find inverses. So the first one, the inverse of a table or ordered pair and graphs. The first one is a table. Now, a table and an ordered pair is the exact same. The only difference is they set up their ordered pairs at the table. So I can make this one an ordered pair simply by making it 0, -3, -4, 2, -5, 1, -1, 4, 2. Those are just, I mean, again, we'll do some ordered pair problems, but they're all the same. Tables and ordered pairs are no different. So there's actually two ways to do this. I would like to call them the easy way and the harder way. I guess they're not too bad. But the easiest way, if you do have a table or a list of pairs, literally just switch your x and your y. So if you don't label this, it's not a bad idea. I guess I didn't say what this one was. Sometimes they'll label what your relation is, and then your inverse, you just put a -1 of x. So let's space for that. But if you ever see that exponent of -1, that means it's the inverse. So g of -1 to the x. A lot of times they don't do it with y, but sometimes I do just to keep the notation the same. When you're finding your inverse, again, don't make it harder than it is. You quite literally switch your x and y. So now my x is -3, my y is 0. You do that for the now your x is y is -4. -5, and your x is now 2, your y is 4. Literally, switch your x and make that list. And I know you guys probably won't use this method, but I want to talk about it just because I want you to have this understanding. So if I list what function is, I'll do that in red. So I have 0, -3, so 0 down 3 is right here. -4, 2 is right here. -5, -1, and +4, +2. The other way to the graph is maybe a little bit easier to look at. We'll talk about in a second. But also, every time you ever find an inverse, if you're looking at a graph, the inverse is always a reflection of the original function. Across the line, y is equal to x. Line y is equal to x, diagonal. You could look at it as slope-intercept form, where your y-intercept is 0, your slope is 1, so you go up 1 over 1. Or you can just look at it as if y is equal to x or x is equal to y, obviously it doesn't matter what order, it just means your x and y are equal. So no matter how much you go over to the left, that's the same number you go down. Or no matter how much you go to the right, that's the same number you go up. So when I do an ordered pair, if I go over 2 to the right, that means I go up 2. If I go over 10, I go up, because the x and y are both equal to each other. So when you're over this line, basically what I always do it is I always count how many steps we are away diagonally from that line. We'll have half a box. For the most part, you won't have anything more complicated than that. So this is what I mean. So this point right here, I'm going to reflect across this line. I go, it's 1, 2 steps away above it. So I go 2 steps away diagonally below that. I go 1, 2 steps to get to that line, so you have 2 steps on the other side. That is that new point. Same thing with all of them. This one, you go 2 steps and 2 steps. Hold on, now I'm going cross-eyed. So from here we go 1, 1, 2, 3. So we have 1, 2, 3 on the other side. This one right here is 1 1/2. That's fine because it works out really well where you have another half and then 1. So 1 1/2, 1 is here, and this last one is a half step, so you'll have a half step on the other side. Now, if you were to go ahead and look at those ordered pairs you just did, every single one of them, you just switched your X and Y. That's what reflecting that did. This one was at -5, -1. This one is at -1, -5. Every single one of them is like that. This one is over 4 up 2. This is over 2 up 4. Just switching your X and your Y. I will show you the one where the graph is, I think, a little bit easier than doing the table. But for the most part, if you're just getting ordered pairs, I think it's just X and your Y. Any questions on that one? So the one that's easier to use the graph, and again, I will show you so you can do it another way. But if you're giving a shape or a function, actually not a function, but I'm not going to get into that. Basically, the easiest way is reflecting it. So you're going to make sure you start at every point that you're ending at, and every little where you change directions, every corner. Now, obviously, you could have it like with a parabola, there's a curve. You could do that, and it's not the worst thing ever, but it's a little bit easier with these ones that have straight lines and corners. So each one of those corners, I'm going to put a mark. Pairs will be reflecting. This one, we're going to reflect those, and then we're going to connect those dots. So this first one is only a half step away, so a half step away on the other side. Next one, and again, you have to make sure you're going straight diagonally. So this one is 2 steps away. So we go straight diagonally 1, 2 steps away down here. Next one is 1, 2 and a half. So we have a half step and 1, 2. 1 step, so we go 1 step the other side. And the last one is 1 and a half. So we go 1 and a half on the other side. From here, to get that shape of the inverse, now you're just going to connect those dots in the same order. Obviously, you're not going to like dot and first connect it up to here and then down here. You're going to go in the same order you did before. One, then I jump over to this other one, jump back over here, and jump back up to the last one. Now, a couple things I want to talk about this before we go on. One thing is, if you do this correctly, where your graphs intersect the other graph, when your inverse intersects the original function, should always be right on that line y is equal to x. So when I went from over here down here, and then the same thing where I intersected, I crossed it, it was at the same point here, same thing here, it's right on xy, same thing here, it's right on xy. It should always be right on that line. Technically, you don't really have to know that. It's a really good way to do this one is to go through those points that I listed in red first, go through and put the ordered pair for those. So -5, -4. Actually, let me do this in red since that's -4. The next one is looks like -3, +1. Then we have +2, -2. +2, +4, and last one, +7, +4. So now, inverse, just like last time, you could flip them. So that's -4, -5, 1, -3, -2, 3, 4, 2, 4, 7. And then once you have the inverse, so if this is the original graph, this is the inverse. Once you have the inverse, graph those ordered pairs. If you go -5, I'm sorry, -4, -5, -4, -5 is that same point. 1, -3, over 1 down 3 is another point. -2, +3 is up here. Over 4 up 2 and over 4 up 7. Those are all those exact same ordered pairs. I will say it kind of depends on this one. Some people like to use the graph better because they like to reflect it across that. They think that's easier. Some people like to go ahead and look at the table after they make a list of those ordered pairs. I don't care what you do. Just make sure you're being careful and make sure you're not making any small mistakes on those. Any questions on those before we move on? So the next one, I want you guys to do these on your own. Honestly, for number 3, I would write them out as ordered pairs just because I tried to do that where if they give you ordered pairs, I give you ordered pairs. If they give you a table, I would answer as a table. But technically, if you write your answer in a table, I won't count your own because, again, it kind of is the same thing as ordered pairs. Number 4, I didn't give you a table, but if you want a table, you can put one in there. Go ahead and do these in a little bit. I will put up the answers to these. All right, so my answers are up there. Again, number 3, don't make that hard to why. Number 4, I kind of showed you both ways of doing it. I personally like to use the graph where I can count that diagonal. But what I will say is a little part of the graph, like right here, it's kind of hard because when you're going to the diagonal, it's almost hard to not get distracted by this line that is not a perfect diagonal. So remember, you got to go straight diagonally perfectly. That's 1.5 steps, so I have a half, and then 1 step on the other side. Tell you, it might not be a bad idea, and it all depends. If you struggle with this, you can start. But it might not be a bad idea to go through a number just like 1, 2, 3, 4, and 5. And the reason I say that is because when I was graphing this one for your answer, I accidentally went from here up to here and then down. That is not an inverse. That is not like anything like what we started with. And it's because I went from this point up to here, not from this point over to here. So that's another thing. Just make sure you're aware of that. And again, if that's going to concern you, if you just make if you label 1, 2, 3, 4, 5, then we have 1, 2, 3, 4, 5 over here. That's going to make it a lot easier to connect those. Or again, obviously, you can write the ordered pairs for those corners, then switch your X and your Y. Again, just remember, at the inverse, you're going to then have to still go back and graph those ordered pairs. Any quick questions on those? So the next one is finding inverse for a function. So in a function, how you find inverse? This is not like the easiest thing you've ever done, but I will say at this point in your mathematical career, you guys should be pretty good at this because the hardest part is solving. To solve an equation. We only did the linear equations, we didn't any quadratics, that'd make it a little bit more difficult, which that might be a good extra credit question, so we can talk about that. But I put 3 steps to these, but really the 3 steps can really be done kind of almost at the same time. The first step is you're going to change your f of x to a y just because that's more what we're used to. So I just write over it. I think that's a little easier. The next thing is you're going to switch your x and your y. What I mean by that is instead of y now, I have x there. Instead of an x now, I have a y. Switch the places. And then the last step, all you have to do is now get that y itself. So now you're solving for y just like we did when we put these in slope-intercept form. And 9 from both sides, cancels. X minus 9 is equal to 3y. And everything by 3. Y is equal to x over 3 is 1/3 x. And 9 divided by 3 is -3. You don't have to label like this, so that's our inverse. And so usually I go take one more step and I say, so my inverse of x is equal to 1/3 x minus 3. Again, you do not have to go to that extent. If you just put y is equal to 1/3 x minus 3, that's fine. Just make sure you realize that's the inverse of what we're starting. So, 6 has a fraction in it, so it does make it a little bit more complicated. And there's a couple different things you can do for this one to start, or to solve this one. I've had people, and I used to do this, where I would multiply everything by 3 right away just to get rid of that. I guess I should say. Let's go ahead, change this to y, and then switch my x and y spots. Now, a lot of people multiply everything by 3. If you did that, you would have 3 times x. 2/3 times 3 is just 2. That's the whole idea, minus 30. So you could do it that way. I like to wait until the end, and then I do the end. So the do from here, add 10 to both sides. X plus 10 is equal to 2 over 3. Now, one way to do this is to multiply by reciprocal. If you cancel out a fraction, you can always multiply by reciprocal. You guys all heard that. However, you can. If you want to use your calculator, that's fine. Or if you're good enough with fractions, you totally can. But in my opinion, it takes a little bit more time, but I think it makes it easier to just do this in 2 steps. Rather than multiply by reciprocal, I'm going to start by saying, this is over 3. There's 3 in the denominator, so I need to multiply by 3. So multiply this side by 3 and this side. Now you distribute, that 3 goes to the x and to the 10. Now you can divide everything by 2. So now we go through, divide by 2. So now is where we have y is equal to 3 over 2x plus 30 over 2 is 15. I like that method better, where we multiply by 3, then divide. Again, you do not have to do it that way, but I think that makes life easier as far as fractions go. Again, that's all there is to it. Hopefully it's not too bad, because again, it's just 2-step equations. If it is difficult, make sure, like I said, we've done this for a while now, and I definitely want to make sure we have this. Go ahead and do number 7 and 8 on your own. We'll put up the answers here in a second. All right, those are the answers I got for this one. For 8, I highly recommend once you add or subtract rather your 15 to both sides, I would multiply everything by 2 first and then divide by 5. And I think if you do it 2 steps, that makes it a little bit easier. That said, again, you guys have calculators. So if you want to multiply by reciprocal, by all means, go ahead. Completely up to you. Okay, last but not least. Are they inverses or are they not inverses? Now, there's actually a third method that we aren't going to talk about because we didn't have a chance to go through compositions this year. Third method, if you talk to someone from another school, not that you guys would ever talk about inverses, I guess just. So the first way to find if they are inverses or to prove they are or are not inverses, and this is my favorite one, I just take one of the equations that looks easiest. X and Y that I solve. If your answer is the exact same equation as the other equation, then they're obviously inverses. Inverse of f of x, that inverse matches the equation g of x, those f of x and g of x have to be inverses. Other way is by graphing both of them and seeing if they're reflections of each other. So I'll talk about that one in a second once we get done with this. Again, I'm going to go ahead and find the inverse of f of x. If it matches this, then obviously we're inverses. My y, I set my x and my y, so f x is equal to 5 minus 4. 4 is equal to 2y. X over 2 is equal to x plus 2. Is that inverse that I just found the same as this equation? Then they're inverses. They both are 1/2 x plus 2, so we know they have to be inverses. Maybe that doesn't make as much sense to everybody else, but I think it makes perfectly sense. I'm saying perfectly sense. Perfect sense. Because if you take one of these are inverses, so I take the f of x and I find it's inverse. That inverse matches g of x, and they are inverses. Now, the other way to do this, and it doesn't make much difference which way you can see where one would be easier than the other, or the second one way would be easier, you're just going to graph both of these. So f of x is -4 is your y-intercept, then you go up 2 over 1. Don't mind that line, and actually, I'm not going to have that line. You're going to have to make sure you pay attention to that. So go ahead and graph that line. Now go ahead and graph x. I'll set this 2. I go up 1 over 2, up 1 over 2, up 1 over 2. Reflections of each other versus. Reflections there or not. So I would appreciate, this one says, are they inverses? So I would appreciate for either answer you put yes, they are inverses. But also, if you're going to do the graph, it'd be nice if you explained that they are both reflections of each other across y is equal to x. I probably will be kind of leaning on that one since it's last chapter and all that stuff. But it would definitely help if you make sure you specify what that line is. And then so let's look at that. I'm going to solve that gx. I'm going to get the y by itself once I split it. So that x is equal to 3y minus 6. Add your 6 to both sides. For y, x is equal to 3y. X is equal to something. Y is equal to 2. Whoops. I did something wrong. Oh, because when I add 6, this should be x plus 6. Sorry. So now 3, I end up getting y is equal to 1/3 x plus 2. If you look at our other line, it is not that at all. It's 1/3 x plus 6, so they're not inverses of each other. Gx, and that was not h of x, so they're not inverses of each other. Now, I know some people say you have to do it both ways. Gx to see if it matches, then find the inverse of this one to see if it matches, but I do not think that's the case. They need to get really in depth in math. For 2, that's not going to happen. Last but not least, again, graph this. We have -6, then we go up 3 over 1, up 3 over 1. And I always like to label mine, so that's that top one, so that's g of x. And the next one, we have +6, and I go up 1 over 3. And so you can tell those are not reflected across that line y is equal to x. And if you can't tell, you can always draw that line in. Again, it's just a perfect vertical line that goes through the origin and through both those corners. There is a chance on here will tell you to explain your answer. Again, if I tell you to explain your answer with the graph, all you have to say is that they're reflections of each other over x is equal to y. If you are solving, the only thing you need to do, honestly, I'm okay with you putting, for this one, for your work, if you say f of -1 of x, the inverse of x is equal to g of x, that's good enough for the next one. Show all your work and tell me the inverse of x is equal to x. And this one, again, doing it the other way, you'd say, no, they're not inverses. And I would simply say g of x, g of -1 of x, is not the same as h of x. And like I said, I don't actually know if on the test, I haven't made that yet, but I don't know if I'm going to make it. If these questions I'll make you explain or not, but it's always good to make sure you get that reassurance. And again, it's not hard to explain, especially once you go through it through. Go ahead and do this last one. you have any questions, let me know.